Good evening, ladies and gentlemen. We had no doubt that the convergence of the minds of Rich Sutton and Tomáš Mikolov would attract an impressive crowd. But we are still more than thrilled that we can see such a fine mix of emerging talent and seasoned academics and professionals from both the corporate and startup world and many other members of the local as well as global AI ecosystem. Today, this meetup is not just us delivering very unique, exceptional content and networking opportunities. For us, it's also a celebration of the successful completion of Days of AI, which is a 2-week long marathon we successfully survived. And it's very important for us, prg.ai, and our collaborators. It's an event that is designed to inspire and educate and inform and generally broaden horizons of numerous audiences, be it children, teachers, students, civil servants, general public, academics, or practitioners. It originated in Brno 2 years ago, and thanks to the recently founded Czech National AI Platform, government agency Czech Invest, and 14 regional organizations, it has expanded to over 200 events across 24 towns and cities across the country. Our endeavor would not have been possible without the contribution of global behemoths, as well as local players, and on behalf of all organizers, I would love to express our gratitude for their support. It has also received recognition from a number of institutions, be it the City of Prague, a couple of ministries, and last but definitely not least, the Czech President, Petr Pavel. Regarding today's event, we would like to thank 2 companies. Equilibra Technologies, how many of you know Equilibra Technologies? Well, there are about 20 of you in the audience, so you surely should. For those who don't know, it's a Prague-based startup that is using game theory and reinforcement learning to build a new generation of algorithmic trading. And given that they have not only Rich Sutton, but also Michael Bowling or Mary Campbell on their board, tells me that they are probably onto something. The second company is MSD, a global pharma that has an R&D center in Prague. They infuse their entire development process, drug discovery process, with all sorts of ML and AI technologies. And given the industry they are in, they very much focus on very responsible and ethical development and deployment of AI. And should you want to know more, there is going to be a booth very strategically located up on the balcony. There's going to be more food and drinks. We believe, assume, hope that Richard's presentation, followed by the subsequent discussion, is going to generate quite a lot of inquisitive questions. And hence we've prepared a Mentimeter. The code is also on the back of your name badges. And you'll be able to see all the questions from the audience, and you can upvote those you believe should be addressed. There's definitely not going to be space for answering all questions, so it's going to be up to Richard and Tomáš to actually decide what questions they'll answer. And without further ado, I'd like to invite Professor Richard Sutton so he can share his thoughts on intelligence, cooperation, and human flourishing.
Thank you. Thank you, everyone. Boy, it's great to see this crowd. It's great to be here in Prague. I've only been here twice, but it seems like a wonderful city. I feel it's kind of like sympathy with Alberta. A smaller place. Actually, Alberta's very big. It's about as big as France, anyway. But it's a smaller place in terms of population, and here in Prague, we're trying to make a center. I think that's really good. We feel like we're trying to make a center in Edmonton. So I feel a lot of sympathy, and I really enjoyed spending some time here, visiting Equilibra. They're doing some exciting things. And I'm really glad to have this opportunity to share my thoughts about intelligence, cooperation, human flourishing, how these things can all work together. So let's start with some perspectives. First, it should be obvious, but let's recognize it. Artificial intelligence is really incredibly ambitious. We seek to understand the human mind, understand intelligence, well enough to create beings of greater intelligence than current humans. That simple sentence is so much. So reaching this profound intellectual milestone, as I think it is, so we understand ourselves and can build people, this will enrich our economies and challenge our societal institutions in so many ways. It will be unprecedented and transformational, but also continuation of trends that are thousands of years old. So this is grand challenge stuff. People have always created tools and been changed by them. It's what humans do. The next big step is to understand ourselves. This is a quest, grand and glorious, quintessentially human. So to put it in perspective, I like this quote from Ray Kurzweil, that intelligence is the most powerful phenomenon in the universe. So if we're going to understand intelligence, is to understand this thing that is so powerful. Is this hyperbole? The most powerful phenomenon in the universe. More powerful than, say, supernova, black holes. Obviously, those things are big roles in the universe, but intelligence, give it 1 billion years, we'll see what we can do. Maybe we'll be moving the stars around. More in my perspective is that this creation of superhuman intelligence and superintelligent augmented humans, this will be an unalloyed good for the world. So many people are worried about it, but I think in the end, it will just be, not that there will be some unfortunate things that happen. Of course, there's lots of unfortunate things that happen. Good and bad will happen. But the understanding of human intelligence, understanding of our intelligence and how it works, I think that will be all good. Now, the path to intelligent agents, in my mind, runs through reinforcement learning and now through large language models. Maybe we'll talk more about that over time, but let me just put it on the table. This is my perspective. And the biggest bottleneck, it's inadequate deep learning algorithms. I think we can do much better. Recently, we published a paper in Nature that makes the point that our current deep learning methods really totally fail when we ask them to continue to learn, rather than just learn once and then be frozen when they're deployed, which is the way almost all AI systems work nowadays. I also feel the greatest impacts and advances, the greatest research advances, are yet to come. In this sense, AI, if it's a race, it's a marathon, it's not a sprint. Now, I want to start just by reviewing this result that I mentioned about deep learning not failing in continual learning settings. And continual learning includes basically all, within reinforcement learning, we're almost always interested in continuing to learn during the life of the agent. It's learning new things, becoming better at old things. So we had many demonstrations, including in supervised learning and ImageNet, but we also did reinforcement learning. I'd like to show that's probably the easiest to understand. So this, what you see, hopefully I can point, yeah, this is a simulated sort of ant-like object, even though it's only got 4 legs. And each one of the joints, these 8 joints, are controllable by a reinforcement learning algorithm. And it has to control those joints so as to move forward rapidly. Here's an ant moving forward rapidly. That's about how fast it can move if it's got a good policy. And no, I'm going to stop that so you don't keep fixating on it. So as I want you to fixate on the graph on the right, which is showing on the y-axis, it's how much reward it's accumulating, or how much reward it's in one trip, one episode of walking, and the reward is received for forward motion. So if you can move forward more rapidly, you get more reward. And reinforcement learning is all about the agent learning to get reward. So, and then on the x-axis we have time, so we see as time goes by, over 50 million time steps in this graph, which is quite long, the performance. And I want to just look first at this. This is the standard learning algorithm, PPO, here, and you see it does really well. It learns to walk faster and faster and faster, faster. And then, like in practice, what researchers do is they get up to here and they end the experiment. But if you continue the experiment for another 1 million, 2 million, 10 million steps, the ant starts performing very, very poorly, and even worse than originally. So here's an ant where it's struggling after many, many millions of steps to move forward well at all. Now, if you look at the next line, the yellow line, this is where we've tuned the algorithms, the hyperparameters of Atom and other hyperparameters to make it perform better. Not the standard parameters, they're ones that are tuned for this problem. And then you do much better. You can keep improving to a higher level and you stay up there a little bit longer, but if you keep training, just doing the same thing with no changes, your performance degrades and eventually to worse than how you started. Now you can solve this method. You can solve this problem. You can use L2 regularization, which works in many cases, but not all cases. Or you can use a new algorithm. This is called continual backprop, and it's a really simple idea. It's just like backprop, where backprop is at the beginning you randomize the weights to small values, and then you start doing gradient descent. And in continual backprop, in addition to that, you also occasionally pick out some of the least used neurons in the neural network, and you reinitialize them so that you have small random weights again. And that's the whole effect. A small percentage, like less than 1 per time step, you reinitialize the least used units. So here you can see a direct comparison between the two speeds. Okay. So now let's talk about why is AI happening now? Why is it now, 2024? Well, the reason basically is Moore's law. Computer power per dollar is increasing exponentially, no end in sight. And this creates a powerful, persistent pressure for understanding intelligence. So I'm sure you've all seen, is there anybody who hasn't seen Moore's law? Just raise your hand if you need to be reminded. Lenka, I know Lenka knows about it. But as you know, over many decades, over more than 100 years, you can plot the. So each one of these data points, each one of these black points, is. Poor guy, Jane, you see a cursor? Each one of these black points is a particular computer at a particular point in time, and on the y-axis we're showing its number of flops you can do, computations per $1,000. And as you plot this, and at least since the beginning of computers, it's been a nice progression that's at least linear, and this is on a log scale. So the y-axis, let me try this. There's my cursor. The y-axis here, you notice these major tick marks are factors of, well, they're 10 orders of magnitude. So each one of these major tick marks is 100,000 times improvement. And so there's been steady improvement. And, I like people to talk about how fast the doublings are. I like to talk about how fast you get an order of magnitude. And you get an order of magnitude every 5 years, basically. And the fact that it's curved, I'm not really excited about the curve. The curve just means that, the fact that this thing is slightly arcing up means that it's actually slightly faster than exponential. Exponential would be a straight line. And we reach roughly the brain power of a person. Up here, it's about 2030. And that's when it will cost $1,000 in about 2030. And this estimate is rough, but it's robust. If you're off by a factor of 10, you just have to wait 5 more years, or it comes 5 years earlier. So there's this pressure or increasing value. If you can understand the algorithms that create intelligence, the computation is becoming more and more available, and more cheaply, drastically, and is expected to continue. So that's why it's happening now. And I think this is inevitable, that humanity will ascend to augmented forms and create augmented forms. So this perspective that ultimately machines will be our successors, or the ascent of man to AI, and this is really an old idea. There's nothing new about it. It's just, higher profile people trying to create fear about it. But I always trace it back when I first said, yeah, this is happening. It was reading the books of Hans Moravec, a researcher at Carnegie Mellon. So I want you to read, these are his words. He says, barring cataclysms, I consider the development of intelligent machines a near-term inevitability. Rather quickly, they would displace us from existence. I'm not as alarmed as many, since I consider these future machines our progeny. Now, you expect your children to succeed you and to be better than you. So he considers these future machines our progeny, mind children, built in our image and likeness, ourselves in more potent form. They will embody humanity's best hope for a long-term future. It behooves us to give us every advantage and to bow out when we can no longer contribute. I think this is actually a very reasonable, mature, and humble point of view. I don't know, it's a mix of anticipating great things and also being humble about our role in them. And also, this is a noble role that we play by being midwife to our successors, but it's also humble. Okay, now I don't, there's a tendency to think of AI as some new and alien thing, but I don't think it is. I think that's not appropriate at all. I think it's one of our oldest strivings, oldest of human strivings, thousands of years. Philosophers and ordinary people sought to understand human intelligence. So I have some examples just to remind you that this is just common sense. If we look at the philosophy of mind in the West, we find, and we have almost every major philosopher has had a major part of their work been about the philosophy of mind. So like John Locke wrote an essay considering human understanding, that's a book, and Immanuel Kant wrote The Critique of Pure Reason. These are thinking about the mind. And René Descartes famously said, I think, therefore I am. And it's not just the philosophers, there are other scientists, non-scientists, all the physiologists and the psychologists, and guys like Carl Jung and even Timothy Leary and Ray Kurzweil. All these people have been fascinated by their work, by their inner workings, and have tried the inner workings of their mind, and have wondered how they worked and how they could work better. So I would put forward to you that this is a grand quest for humanity. It's not just narcissism. We're studying ourselves. We are trying to understand this most powerful phenomenon in the universe, as Kurzweil said it. And so I think understanding intelligence is the holy grail of both science and the humanities. It's a great and glorious prize, a noble endeavor. Okay, but can we define intelligence? So I'm going to go through some definitions and tell you the one that I like. Intelligence is, one meaning is that it's behaving like a person. This is sort of the idea of the Turing test, and maybe we're seeing more of that. I don't really think it is what Alan Turing said, but anyway, we attribute it roughly to them, and we very much see it in the days of generative AI, that behaving like a person is maybe important to intelligence. If you just look in the dictionary, they will say intelligence is the ability to acquire and apply knowledge and skills. That's not so bad, actually, of a definition. This is the founding father of psychology, William James, and he says actually didn't talk about intelligence, he talked about mind. But I think it's the same thing. The hallmark of mind is attaining consistent ends by variable means. It means you change what you do to get what you want. It's like trial and error. It's a goal. And continuing in this, John McCarthy, one of the founding fathers of AI, said that intelligence is the computational part of the ability to achieve goals. So notice it's an ability, and it's the ability to achieve goals like constant ends, consistent ends from variable means. And it's the computational part. You're not achieving goals just because you're stronger or faster or have better sensors. Okay, so I kind of like that one, but today I made a new one, and I wanted to offer it to you guys. I want to say intelligence is the ability to achieve goals by adapting behavior. So one thing about this definition that's implicit in it is that intelligence is a kind of real-time signal processing. It's signal processing. This intelligence is exchanging signals with its world, and so it's a kind of signal processing. It's the kind that achieves goals by adapting its behavior, where behavior is the agent side of the interaction between the agent and the world. So generally, the agent maps a summary of the interaction so far, which we might call the state. Often in reinforcement learning, we call it the state, and we map that to outputs like actions. And goals, we can also spell out what we mean by that. Goals are outcomes that are achieved despite variations in the agent's input. So the world does different things, the agent does other things to compensate for those and achieve the goal no matter what the world does, or to some extent independent of what the world does. Now I want to just mention reinforcement learning. Reinforcement learning is my area. You know, I'm kind of did some of the important work there, did the textbook. So reinforcement learning hypothesizes that all goals can be thought of as maximizing the sum of a scalar input signal called the reward. Everything is about, all goals can be thought of as maximizing the reward. But that's just a way of formulating goals. Intelligence is the ability to achieve goals by adapting one's behavior. Okay, so now let's move on. I want to go in a somewhat less technical direction, but just ask you some basic questions. Like, should we think of all these agents in the world, all the people in the world, should they have one goal, or do they have different goals? Now, in reinforcement learning, we're building these agents. Each one could have a different reward signal. Each one, I mean, obviously, if pain and pleasure are part of your goal, as part of your reward signal, then each agent has its own pains and its own pleasures. And so this is like in nature, every animal has its own pains and pleasures. And so I would say that, you know, even though we care about the same things, in some sense, we all care about food, but, you know, I care about my food and you care about your food. It's like not that the same goals are the same, it's that the goals are symmetrical. They're symmetrical. We each care about having good food and clean air and a place to stay and the respect of our friends. So in AI and in nature, different agents have different goals. I think that's just sort of obvious. Sometimes the obvious things are the hardest to see. I think that's a moment's thought. It's obvious that we all want different things. And I think our economies work best when different people have different goals and different abilities. They don't rely on people having a shared common purpose. They each pursue their goals, and then they exchange and they cooperate so that it works out well. So I'm going to call this decentralization. Decentralization means many agents each pursuing their own goal. And cooperation is when agents with different goals interact to mutual benefit. Cooperation, decentralization. This is my happy place. You know, I just went, you know, the bottom line is that agents can live in peace even when they all want different things. So we don't necessarily have to make AIs that are aligned and our servants, really, and do what we tell them to do. They could have their own goals. They can all want different things, and we can still live in peace. In fact, this is largely the way our societies are structured already. Because we are the man that is most cooperative, the animal that is most cooperative. I call Homo cooperativus. We cooperate more than any other animal, and that cooperation is facilitated by our uniquely human things like language and money. Humanity's greatest successes, I would say, are our cooperations, our economies, our markets, our governments, and our greatest failures are our failures to cooperate, like war, theft, and corruption. This decentralized cooperative view is an alternative to the idea that we all are striving for a common purpose. And I find it more elegant. It's more sustainable. I find it more sustainable, robust, adaptive, and flexible. And so, as I said, humans are better at cooperation than any other animal, but at the same time, we're terrible at it. You know, we still have wars. We still have theft. We still have corruption and fraud. So we struggle to do this thing. We struggle to cooperate. It's not easy. It's not always possible. Sometimes one of the agents is not sincere. And there are always some who benefit from not cooperating. There are cheats and thieves and con men and weapons manufacturers and dictators. Cooperation needs institutions to facilitate it and to punish the cheaters. And so that often leads to a centralized authority, which can help cooperation, but that will often poison it in the long run when you have authoritarian or sclerotic governments. Okay, so the main message I'm trying to communicate is that centralized control is the opposite of decentralized cooperation. So when you think about centralization and control, those are forces leading you away from the ideal of decentralized cooperation. Okay, just a couple more slides. So I want you to notice there are many calls for centralized control of AI. Do you want to control the AI's goals? We want to pause or stop AI research. We want to limit the power of an AI. And this is all for ensure safety. Sometimes they want you to require that an AI disclose that it's an AI and not a person. And so this is similar, in my view, to the many calls that we see nowadays for the centralized control of people. The controls of speech and the controls of the distribution of speech through the media, the controls of trade and employment and financial transactions to economically sanction one country or another. These are calls for centralized control. And these two sides, right and left, they're eerily similar of each other. They are based on fear. They want us to fear the AIs, want us to fear the foreigners, want us to fear the Chinese or the Russians or the Iranians. So they're all about, us versus them. They are not fully human. They are different. They're there. They are demonized, and we claim they can't be trusted. So I guess my final slide is that flourishing, let's recognize that human flourishing comes from decentralized cooperation. Humans are great at this, but also terrible at it. Cooperation is, of course, not always possible, but it's the source of all that is good in this world, and we must look for it and support it, seek to institutionalize it. Now, if we look with open eyes, it's easy to see who is calling for mistrust, non-cooperation, and centralized control. And we should resist those calls, whether they are about AIs or about people. I think this is a useful lens with which to view all calls for controlling and structuring human and AI interaction. Thank you very much. Oh, many questions. I think this first one is a reasonable question. The reinforcement learning system, standard PPO, it just fails. So we ask for a cause, and whereas it's an observation, which has been seen in many, many times. It's in the ant. It's also in just supervised learning. If you set up a supervised learning problem where you have to keep learning to classify new things with the same network, it also crashes. So there's lots of things you can point to. You have many units become dormant or dead over time. The system basically loses its ability to keep learning. And best by resetting portions of it, we can keep it alive and thinking. I don't know if we really have a cause, but without trying too hard, we can find methods that work much better. We have to keep innovating in our methods. If you look at deep learning, actually, there isn't that much innovation in the core algorithms. The people are very happy to experiment with different ways of handling the training set, but they almost never want to change the core algorithms of backprop and Atom. So, I don't know if it's super good. This last question is interesting, and let me speak to that a tiny bit. As I said, in reinforcement learning, there's only one goal, which you're trying to get reward. And yet, and so I'm going to argue both sides of this, but let's stay on the side that says there can only be one goal. Because if you think about it, in some sense, there can only be one goal. If you're choosing among your goals, then on what basis are you making the choice? You can only call it a choice if it's made on the basis of some other preference that you have. And that other preference is the ultimate goal. And so you only have one ultimate goal, but you can have multiple sub-goals that you could choose to pursue in pursuit in support of that ultimate goal. And that gives us something very much like value pluralism. We can decide, I'm going to go to graduate school and become skilled at, I don't know, computing science, biology, whatever it is. You could choose to study how you could become a better soccer player, or any activity. You can choose the goal of succeeding at this job or another job. So we do choose things, we choose sub-goals, and not only does it happen, I think it's an important insight into how the mind is structured, that we organize our thoughts and our possibilities and our model of the world in terms of outcomes, in terms of opportunities for achieving sub-goals. Okay, maybe I could slip in one more. Okay, yeah, I think this is a very good one. This one here. Do we, as mankind, cooperate? I think you have to meditate on this, because I say it's obvious, and the obvious things are sometimes the hardest to see. So this person says it's obvious that our goals need to overlap. Well, because I am explicitly proposing they don't need to overlap. But still cooperation is rational. And it's basically by exchange. So you need to raise your family, and I have a stopped sink. So I call the plumber, and he helps me. He's happy to be paid to fix the sink, and I'm happy I don't have to learn how to be a plumber. And our goals are totally non-overlapping, and yet this is how our economy works. Yeah, okay. So, let me say it again. Thank you very much for your attention.
Thank you. Thank you. prg.ai was founded on a premise that the Czech Republic has actually a lot to offer in terms of world-class potential. And so when we were thinking how to infuse some of the Czech genius into this event, it was no-brainer to approach Tomáš Mikolov for obvious reasons, as he's arguably the most successful Czech scientist who has most fundamentally shaped how we think about human intelligence. So I would like to invite him on stage, and we are very honored that he's accepted invitation to interview Richard.
Hello.
Yeah, hello. Should we start, or will Lenka keep introducing?
Yeah.
Okay. So it was very nice to listen to your talk and to have you here. So I had a lot of things on mind that we can discuss, but I will probably start what we were discussing just before our talk, because it's kind of like easy question in some sense. So what do you think about this big news from the last like week or two about the Nobel Prizes for Physics being awarded for AI to Jeff Hinton, because I think he was like very influential figure. Yeah, okay. Very influential figure, like a person working on neural networks for pretty much all his life, and now neural networks did really take off, and for some funny reason he did get the Nobel Prize for Physics, and at the same time the last news that I heard in media from him was that he was actually warning about AI being more dangerous than nuclear weapons, and it felt very strange to me, because the Jeff Hinton that I remember from the times when I was in Google Brain like 10 years ago, a bit more, he was much more optimistic actually. So do you have any opinion about this? Like, what do you think could be this reason for his switch of the opinions?
Thank you, Tomáš. As you know, there are many questions embedded in your question. So I don't know what order to say them. Jeff Hinton is a great scientist. As he tells the story, he was totally surprised to be awarded the Nobel Prize in Physics. You know, it was like they called him up in the middle of the night. He's groggy. He decides to answer the phone. These guys saying, "Oh, it's a Swedish accent." He's saying, "You know, you've won the Nobel Prize in Physics," and he's sitting there saying, "Right. This is a prank," and but they kept going, and then you know he like got no sleep that night. Everyone called him, and so he says that he was totally surprised, and so we can't blame him, and it's true that it is something that's almost worthy of blame, because like all the physicists I think around the world are just totally going mad. You know, can't we find a physicist to get the Nobel Prize in Physics? And it's a bit, I think maybe there should be a Nobel Prize for computer science or AI or math. You know, that's against the rules, but maybe they were feeling the need to stretch those rules. You know, neural networks are such a big deal in the world, and you're a prize-giving agency, and you can't give a prize for this very important scientific development. I think it would be annoying for them. And so maybe they found a way to stretch the rules, and maybe that's not terrible. Physics, though. Why did they have to? Yeah, anyway. Jeff is a great guy. I was surprised that he's backtracked and doesn't say that, you know, it's all a good thing to understand intelligence. I don't really understand that, and I was disappointed by it. I think there's too many fear mongers. There's too many warmongers too, but I guess they're not unrelated according to my thesis.
I see. Well, I didn't understand it myself. I was wondering whether you have any idea, but maybe we will figure it out later. Like, would it contribute to his change of mind? Maybe one of maybe the smallish explanations could be also like that. If you talk like in this big way, like AI is more dangerous than nuclear weapons, it's an existential threat and so on, you are much more likely to get into the media and people will talk about you much more than if you give a talk, AI is nice and it's gonna help us to solve some like problems in the future. Like nobody will like contact you, and certainly not the Nobel Prize Committee. But maybe that's one explanation, that there are like thousands of very accomplished AI researchers who are much more modest in their claims, and they are not so much afraid, and then we don't really talk about them because it's much more boring than these kind of like sensationalist positions. That's maybe one small explanation from my side.
But Jeff is a great researcher, and he doesn't really need to do this to be appreciated forever. So you'd have to theorize that somehow he's seeking the limelight of popular media, which is possible, but he's such a great scientist.
Okay, maybe we'll change our opinions as well, because I, as you, don't really see AI as a danger, because I see it as basically a continuation of development of the technology that allows us to solve problems, similar like computers or calculators or basically machines that we keep building. And of course, there are dangers associated with it, because you can build an airplane and turn it into like a bomber, and you can make pretty much any powerful technology into a weapon. So sure, there are like kind of like dark sides, but then you can be discussing dark sides of everything, and we would have to stop doing pretty much anything if we would want to be 100% sure that nothing bad will happen. So I just feel that the discussion about like the dangers are like overblown, and sure there are dangers, but there are also like the positive things, and if the positive things are much more have much more basically likelihood and weight, then we should be of course like careful about like these developments, but not spend all our energy on actually just discussing the danger. So maybe I think that that's something that also people were asking about, the questions about this big filter and the other arguments that maybe we don't really see the other life forms in the universe because they got wiped out by the AI that they did build, and these science fiction topics, which I think we can also address if people want, but I just find it a bit too like speculative and funny, to be honest, to let's spend too much time on it. So actually I would have maybe a little bit more like technical question, because you started your talk about like saying that language models are not...
You must give me a chance.
Okay.
to before we go there. So there's a natural concern. It's a big change, and it will be, I think, a fundamental change. I think that at the same time, there are individuals or organizations that really do stoke the fear. They've set out to try to control things and gain power through it. But what do you think about it? So my bottom line is what we're talking about is understanding intelligence, understanding who we are. This is and creating more intelligent beings. And I think there are many things wrong with this world, but too little intelligence, that's not one of them. Or too much intelligence. I got it the wrong way around. Forgive me. Too much intelligence is not the problem. We have people making non-intelligent choices, and I think that's my bottom line. I mean, it is radical. It is radical to imagine the far distant future, or the future that's coming, which may not be that distant. There will be changes, and we can't ignore it. You know, people would like to be able to ignore things. Most people, and you should not be ignoring what's happening.
Okay, I wanted to follow up with what you were showing in the slides in the beginning, when you were basically advocating for reinforcement learning being like much better option for like developing artificial intelligence. If I understand it right, then
I don't think I argued it.
Okay.
I said that's what I believe. Yeah.
Yeah, that's basically.
It'd be much longer to talk if I argued for it.
Yeah, and. Well, I was wondering, because actually I agree with the point that reinforcement learning is actually a very interesting research topic, because you can have much more kind of like autonomous machines, models, robots, whatever you call it, artificial beings, to do much more with much less input, because you can be just saying basically kind of like yes, no, and everything else, the behavior of the robots or whatever it is more like emergent property of some more basic principles, which I actually like very much. Of course, like many people are now like super excited about supervised learning, where you see the results much more quickly, and I think that it's kind of like difficult to really explain the limitations of supervised learning, because when people see a computer that chats with them and says something like "I love you," and they already think, "Oh, the computer has emotions and the AI is already here." It's difficult to explain it to people who are non-technical that actually it's not as great as it seems. But what I actually wanted to ask you about is that you can actually make that trajectory even longer. You can go from supervised learning to reinforcement learning, and then even continue. You can think about like what could be even like less supervised version of reinforcement learning where maybe even the rewards can be actually emergent properties of something more basic. So what do you think about like ideas that people call, for example, artificial life or complex dynamical systems, things like this?
I think it ends with reinforcement learning.
I see.
Yeah. And I don't think actually reinforcement learning is that hard as a technical idea for people to understand, because reinforcement learning is just like learning by trial and error. It's what animals do, what people do. If you have to explain learning by trial and error is I think the easiest thing to understand. Supervised learning, the question is, where does this training set come from? I remember I saw the interview with Jeff Hinton on 60 Minutes, and then at a certain point the announcer came in and said, "Oh yeah, here are some examples of machine learning, and here's some robots learning to play soccer. They kick the ball and they get a goal." And he was explaining reinforcement learning. You try different things until it works. This was the background to Jeff Hinton, who never does reinforcement learning. But the easiest example for the regular people to understand, is trial and error learning from the world to get what you want.
Yeah, actually, I asked similar question. Actually, when you are mentioning Jeff Hinton, I also asked him this question like many years ago, and his answer was, I would say, more like mainstream in a sense that not like that we would have preference, but supervised learning in his view was much faster, basically, than if you are doing either reinforcement learning or some evolutionary algorithms or like trial and error, which is kind of true. I just feel that. It's basically what you were saying. It's very difficult to interpret how far did you get with supervised learning, because you can get like a amazingly performing system which seems to be doing a lot of things, but in the end it doesn't have the capability to kind of like evolve, or whatever I would call it, like basically gets more complex over time by itself. It's mostly like copying basically the examples from the training set. Sometimes when the training set is huge, it can be like the whole internet now as it's for the language models, then it's very difficult to like explain, I would say, to like a normal audience actually what are the limitations of the learning, because you can just come up with any basic examples like that what is the name of some guy somewhere doing some job, and the model will know it because it just knows the whole web. So it's very difficult to like explain what are the limitations of these supervisedly trained models. But I think that my view, for example, for this is like whether the system has kind of like limited potential, if I would say it like that. Like whether there is possibility that if the system, this artificial being or artificial intelligence that we can call it, if it would kind of like replace us, as you were saying in your slides, and be the next generation of life on the planet Earth, then does it have potential to kind of like get better and better, like possibly infinitely long, or does it have some upper bound that is fixed and we know what it is, and it will never step up beyond some kind of boundary? And that's my explanation why I think that the language models, even if I like them a lot because I did contribute to this technology a lot, I think that AI or AGI can be built around language models, but it would have to have incorporated further ideas that are missing there, because the boundary is there. You can train it on more data, but the boundary is still there, because you stop training a language model, it will have the weights fixed, and it will stay the same forever. It will be the same if you run it for a billion years on billion computers. The language model will be exactly the same, and it will never change. Of course, you can try to train it on the data it generates itself, but then it will actually degenerate. You are kind of like showing similar things in your slides as well. If you train things too long, then basically it kind of overfits, and the performance gets worse. So of course you can solve it by reducing the learning rates or adding regularization to the point that you basically stop making changes to the model. Sorry? Sorry?
Question.
Yeah, sure.
I always think of the Kurzweil quote. Intelligence is the most powerful phenomenon in the universe. And we want an understanding of intelligence that can live up to that very ambitious statement. So if you're just learning from training sets, you're not going to become the most powerful phenomenon in the universe. You can only become as powerful as whoever's giving you these training sets. If you're mimicking people, like we do with large language models and other generative AIs, you're only going to be as powerful as the existing people. So the limitation, I think, that you mentioned is real. We want sort of open-ended abilities, and that's our ambition for intelligence. It has to be able to try new things, create new things, and be open-ended. Supervised learning. One thing I was saying, there's no animal that learns by supervised learning.
Yeah, well, I was actually thinking the same. That's why I was asking that question to Jeff that long time ago. And as I said, like his answer was that supervised learning is just orders of magnitude faster than the other things, and that's basically the explanation. I think that some people also have the argument that maybe you can combine things in the sense that supervised learning can be kind of like a pre-training phase where you just kind of like jump faster to some level of competency of the model, so they can be doing some basic things. They know the basic words in English, they don't have to discover them. And then from there, you can continue, say, with reinforcement learning or some evolutionary stuff or this artificial life. So maybe that's also like a way how to combine the ideas, but of course, like that's very speculative.
You know, I don't think supervised learning was initially ever expected to be a whole agent. It was expected to be you know, pattern recognition. That's what it was originally called. It was called pattern recognition. You're looking for patterns. Maybe you'd use them to predict what's going to happen next. It was never. Nowadays we use it to, you know, here's the situation. This is what you should do. And, you know, if you're an animal, that would be like, okay, here's a state you find yourself in. Here's which muscles you should twitch. You know? It's kind of weird that we. Okay, now large language models do amazing things. But they're just mimicking people, maybe without the word just.
Maybe I can add one more like defense of supervised learning, even if we are kind of like talking badly about it now. But there's also like this argument that much of our intelligence, actually of like humans or maybe animals, is based on prediction, that we are kind of like continually predicting your surrounding environment, or you are trying to predict what the other person says, and if you can do it, then you probably understand quite well what the person is talking about. And whenever we are making the predictions, as the time goes, you see whether the predictions were right or wrong, and if they were wrong, you are updating your model, and this way you are building kind of like your understanding of the surrounding world. It can be the language, it can be kind of like eyes, the vision, and everything. And there are like some neuroscientists who claim actually that some of the principles how the brain works, that there's this neocortex that's doing constant predictions and trying to find some inconsistencies between the predictions and the sensor input, so that whenever this happens, then it gets propagated further to some higher level modules that perform the thinking processes and so on. So maybe that's some explanation that supervised learning maybe can be this part of some intelligent machine, so that it makes the learning process easier.
Yeah, a whole bunch of things I want to say about that. You know, but first, let's say something. Let me say something positive about supervised learning. Like in reinforcement learning, we are consumers of supervised learning algorithms. We need them in order to build our basic maps. We call them function approximators. You know, given a constructed example, you have to remember it. And so we need this ability. And you need it for both prediction and control. But let's talk about prediction. Prediction is an enormously complicated subject, and it's not really modeled well as supervised learning, although supervised learning researchers frequently call the output of their systems predictions, and they could be predictions. Like you could do something and predict what will happen, and then you see what does happen. This is not classical supervised learning. Classical supervised learning, the training set is just an arbitrary thing that a human has prepared for you. But if you were a robot and you were doing things, you might predict what will happen next, and then you see what will happen next. And this is beautiful because no one has to construct this training set. You just do, and you see what happens. No no human input. And so it's totally, completely scalable, proper prediction learning. Now, it's not that simple, though. It's actually massively more complex. The way that sounds right is exactly true and proper, but it's only simple if you're trying to predict like the next token in a sequence of tokens. And in our lives, what we need to predict is almost never that. What we need to do is predict, like, if I behave this way, will it work out better for me in the long run than if I do another way? Or even, if I pour out this can of water on the floor, then the floor will be wet, the can will be empty. These are my predictions, but they're not one time-step predictions. I mean, a time step it can't be more than 1/10 of a second. And we have to predict lots of things at higher level, at larger time scales. Okay, so, but before this seems now too hard to imagine, I'd like to remind you that we do this in reinforcement learning. We make long-term predictions. The basic thing that's learned in reinforcement learning is called a value function, which basically you're predicting at every moment in time how much reward you're going to get in the long run. The sum, or your discounted sum of future rewards. It's a long-term prediction, and we have really well-developed algorithms for doing this kind of prediction. And so they're temporal difference algorithms, long-term prediction. They're not supervised learning, why anyone would call it supervised learning. But they do, as a piece of them, they require a function approximator, something that will take the examples that are created by interacting with the world and learn on those. And that level is close to supervised learning. I mean, nowadays they are done by backprop, basically, to learn the value function in deep reinforcement learning. Backprop and temporal difference learning. So they are all coming together. Yeah. There's a lot of hype, okay? That's my pause. My pause is I'm just worried that we can't just be friends. We should just be friends, The patterns, life, interaction with the world, you require the ability to recognize patterns, and you require the ability to predict over long periods of time. And it's just people get to attitudes, and they think, well, I can do everything with gradient descent, or I can do everything with, something is enough, and we don't need anything else. Like Jeff Hinton said long ago, reinforcement learning could be good, but it's way too slow, and then you just dismiss it. Well, the problem that reinforcement learning solves is vastly harder. It's the problem of interacting with the world, as opposed to taking a training set and just remembering and generalizing from the training set. We can all get along, and we're trying to understand the mind and its various pieces and the whole structure of the problem, how the pieces fit together.
Yeah, I just wanted to comment a bit on the part of the language models and the supervised learning, because I remember the times when actually people used to use different terminology. They would call language models unsupervised learning, because still you are using, exactly what is the word in the sequence. You are propagating the gradients, you're using the standard algorithms, but you don't need the human annotations. Later, because there was this issue with the terminology, people started calling it, I think, self-supervised learning, so that it would be somewhere between unsupervised and supervised. I think it's sometimes confusing to talk about these things, because it basically changes even over the time, even the terminology itself. Let's see if in the future people will just rename it again, but we shall see.
Along these lines, me and my colleagues, we have proposed different terminology. Instead of talking about supervised, unsupervised, semi-supervised, reinforcement learning, the things we have to do is we have to predict and we have to control. Predict, control, and you have to have three. The third one is representation learning. You have to learn the representations of your state. So we're moving ahead to what we all want to do, I think we all want to do, ultimately, is control. We want to make decisions that affect the world and then have a good effect. A full agent has to take action. And then in service of your action, you make predictions. You predict how well things will proceed if you behave this way or that way, or the way you did behave, and you use those predictions to better assign credit to control decisions. And for all that to work, you have to be able to generalize, and good generalization requires forming the right representations. So yeah, so those three can be a different way of organizing the space of algorithms.
Yeah, I will actually ask about this because I also remember some famous scientists from a long time ago who did not think so much about the control, and they were trying to make some more simpler theory of what the intelligence could be. And you probably have heard of Ray Solomonoff and algorithmic probability and these kind of arguments that if you can discover pretty much all the patterns in the data, and then that's kind of maximize the intelligence. You can be doing optimal prediction, and optimal prediction is very similar. It's basically the same motivations with language models, actually. Of course, we don't have optimal language models at the moment, but we see that as we are making better and better systems that are better at better prediction, we can turn them into very useful tools. Maybe it's not like a full AI as kind of standalone life form, because there's not control. The language models are not trying to control us. They are not actually having any motivation to do anything. They just compute the most likely continuation of sequences. But even then, that actually is very useful. And if you think about, say, future where the AI that we develop is working together with us as humans, kind of in collaboration, so not really like the AI that you are showing, for example, in the slides that would replace us, but more like AI that is superhuman when it comes to certain type of abilities to reason and to think. That, for example, if I have a problem that I want to solve some disease or discover some new drugs that will solve some big issues, that maybe this super intelligent language model that has no control, no desire to do anything, no motivation, that can be still a very useful tool for achieving these goals. So maybe actually you can have kind of a system that is a combination of a human with the control and then the machine that is actually having much bigger memory and much higher processing capacity, but that will be used as a tool for the human.
So remember that Moore's law continues. And Moore's law says that inexpensive computation is becoming more and more plentiful. And so that will have enormous impacts. It has been having enormous impacts on all fields, and so computation, just computation, not intelligence. Let's be a little nuanced and distinguish between the impact of computation and the ascent of understanding of intelligence. So something like AlphaFold. AlphaFold is not like an agent. It doesn't have purposes, doesn't have goals, and yet it uses lots of computation. And so should we call it intelligent? Should we call it AI? I want to say no. I want to say there's lots of things that are using computation and that are happening now, and they're really super useful tools, but they're not intelligence. And of course, but we are calling them intelligent. And the reason, I mean, it should be obvious. Like if you go to the drugstore now and you buy a new toothbrush, the advertising for the toothbrush will say it has AI in it. If you get a washing machine, it says it has AI in it. When I first started up, 40 years ago, you would buy a terminal that you'd connect to your computer, and everyone wanted to buy the intelligent terminals. Intelligent terminal meant it has 2 fonts in it. There is cachet to having AI or intelligence in your product, and so people reach to want to say that their system has intelligence and not just lots of computation. So this is going to happen. When computers were first invented, they were giant brains, right? You guys don't remember, but it was the giant brain, and all it did was do your payroll. But it was the giant brain, this intelligent thinking thing that could do all of that. This is the way it's always been. And I think it will moderate. I bring up the ancient thought about computers as being giant brains. We don't think that anymore. Now we have to say you have to have a neural network, because things, appearances or descriptions and names change over time. When we had a computer, when you first had a computer that could do large sums and multiplications, that was like a brain. That had all the hype about brains. But now, we just accept, sure, computers can do sums faster than we can. And in a sense, I think we may end up similar feelings about the generative AI, the large language models. Yeah, they are now fluent in language. They can come up with the words that are most, quickly, most naturally expressing certain concepts much faster than a poor human. They just have different abilities. I'm not sure we'll call all these things intelligence in the future. They may be just, as you say, really, really useful tools that use a lot of computation.
Yeah, cool. Well, I was also having this question in mind for some time, that we see that AI is, as the technology is evolving kind of fast, a lot of people work on it, and it's also making a lot of money. Of course, it's not the AI that you are talking about. It's more like machine learning or applied statistics or whatever you would call the current algorithms that are optimizing the display of the ads at Facebook and Google and so on. That's actually where most of the money actually from AI is coming from today. We would look at the big sums worldwide. But the question that I have is that I certainly did see a lot of how to say it, basically, in the US, I did see that a lot of companies were adopting this technology very quickly and moving forward, as well as the society. Universities were adding these courses quickly, and there was kind of some kind of working ecosystem where you would have universities producing students, going to some startups, selling the startups to companies making a lot of money by selling the ads to people, but also doing other things like spam detection and so on. So it's boring, but also you can use a lot of machine learning there, and that's also very useful. And if you add it all together, then many of these companies that are on the internet, again, like Google, Facebook, and so on, that cannot transform into AI companies by replacing component by some kind of machine learning algorithms. And that was working because it was helping each other. The companies were later giving money back to the universities and buying the startups, and so basically have a working ecosystem there. But we don't really have it here in Europe, and especially I would say in Czech Republic. So I don't know if you know about the situation here, or if I should describe it. But would you have some recommendations what people here, because this event is also organized by prg.ai guys who actually have this in mind. How can we promote adoption of this technology here? And then if you want people to seriously work on this kind of technology, where actually winner takes all, how it works, then you really need a lot of money. And it seems that the big ingredient that is missing now in Europe is the money, the big tech companies, and because you are missing these components, then you can have as many smart people as you can imagine, but much of their potential is underused because they could work on some next generation of AI algorithms, but either they move to the US at the moment or their talent will be wasted.
Yeah, these are questions that are above our pay grade in some sense. We're just scientists. And it's a mystery to us how it's done. I mean, you could say that the way to do it is to go with the hype and hype up even more than the other guy. Maybe that could work. But I don't like that. Anyway, I can say a little bit how we've partially done it in Alberta. And I think it's a sound strategy. We have emphasized the science or the fundamental research. So we've tried to. Alberta has always been a little bit behind on the application and the money making. But to the extent that we've become an important part of it, it's because we have established a good base in research and at the university and at institutions, the AMI, Alberta Machine Intelligence Institute. So if you do get, a reputation for scientific excellence, that can persist. And it has to be maintained for a period of time, 10, 20 years. And you can be known for that, and you can strengthen that. And then around that, one can build companies. That's what we've done. It's worked out pretty well, and we still wish we have attracted more companies. But it seems you could do that here with the universities and with, I know Equilibre has a strong commitment to doing fundamental research, and you're here, of course, Tomáš. I think this is the nucleus of an established excellence at the various universities here, like the Charles University and the Technical University. And I'm sure I don't know them all, but I think you can have a good nucleus.
Yeah, I guess we are all trying, but so far I'm a bit skeptical because I don't really see much results. But again, we are trying. I think Lenka also already wants to maybe ask some questions as well.
Yeah.
As a true scientist, you should say you just want the fundamental research to be done, and you don't care if it stays in Prague, or if you don't care if it stays in Edmonton. I do feel both ways. I feel I want to strengthen my local environment, but science is everlasting, and the individuals can move around. And it can be all good.
But it can be a bit frustrating when you see that something.
But you're a part of the world community of scientists.
Yeah, but if you did work on something that is making a lot of money, and like you have the language models these days are super popular. I remember the days when nobody was really working seriously on this technology because language models were dead 15 years ago. You wouldn't even have papers about it.
How old are you?
42.
42. Do you remember when we had expert systems?
I've read about it.
Yeah, you've read about it. So there's this thing back in the 70s and the 80s called expert systems, and it was like the biggest thing in AI, and it was just going to make all the money, and there were companies, and it was sort of just like now. And then it all went away. But the science gradually built up. I'm sorry.
Fantastic. On that note, thank you. We shall ask, the audience that has already provided some lovely questions. So, gentlemen, I shall scroll. I shall ask the first question, just because it sounds quite interesting. And then I will leave it up to you to choose what questions you want to answer. We have about 15 minutes or so. So, on the view that AI is our brain children, I wonder who the we is in this vision. Does it matter that currently the full diversity of humanity is not represented in AI development? Richard, question for you.
What do you think? I want to say no. The development of AIs and the deployment of AIs, what will it be like? Will it be deploying? Suppose we understand intelligence, so anyone could create an intelligent instance and give it a set of goals. You said mind children. So the intention, and let me just say the intention, we can decide if we believe it all. The intention is that they are humanity's mind children. They are the descendants of humanity. They will reflect us, and we are profoundly imperfect. So we don't want them to totally reflect us, just like you don't want your children to totally reflect yourselves. We want to develop, like society evolves, values evolve, things that we consider progressive and straightforward now were considered just impossible to accept decades ago. We have to expect there to be changes. They're meant to be humanity's children. They're not going to be controlled by guys like me. I think I'm trying to evolve, be part of inventing the ideas and the algorithms, but then how that evolves in the future is up to our society. I don't want to say it's up to our governments. I want the governments as little involved as possible, but I want our society to decide what they want. And yeah, a lot of that will come out of our institutions and our companies.
Tomáš, do you have a take on it?
Well, not really. I was just thinking when we were discussing like who is gonna be like the father of these AI childrens in the future. I was just thinking maybe something differently about like what we didn't actually discuss yet today. Like what is actually like or is there some goal of life? Because if you think of it, we are discussing this thing that there will be some AIs maybe replacing us in the future, or maybe complementing us. Maybe the biological life will transfer into some kind of like a mechanical life that will be evolving much faster. Maybe that's the view. But I think then the big question that maybe we already can be thinking about is what is the long-term future of life? You were talking about moving the stars and so on, billions of years from now. But I think that there are basically two maybe possibilities, that either the life can be evolving kind of like forever, trying to find better and better versions, kind of like finding a better strategy in a game that has so many states that there's impossibly many strategies so that it can be evolving forever. Or maybe there's some end goal of life where it's kind of like perfect already and there's nothing to improve. And I think that it's also kind of like funny to think about the second thing, because if there would be this perfect life, then if you imagine how would it look like, then I actually tried before, then what is actually the difference to kind of like the dead matter? Because actually the goal of life is kind of like self-preservance, survival, and if you get like a stable structure that cannot be destroyed anymore, like holes, of course, then maybe that's the end goal of life, because then you basically become immortal and nobody can touch you. So there are basically these two options. Either you get this infinite complexity growth, or maybe you get some singularity, maybe one of these two.
I always think about like a coral reef or a jungle. A jungle has so many different kinds of organisms, and it's only partially stable. It's in a very dynamic equilibrium, and no one is in control of a jungle. And from some points of view, the jungle is very inefficient. Like in the jungle, you have bushes, and then the trees grow really tall, so they shade, so they can get the sun, and then they shade out the bushes and kill them. And so wouldn't it be better if you just stayed low? If everyone, you also had to build these huge trunks for the trees. It'd be better if you just had small. If you want to take advantage of the sunlight as most efficiently as possible, you would just like have grass or something. But because they have to grow tall and outcompete the bushes, you end up with this enormous diversity and so many strategies that interact, and so you get diversity and complexity, and also a form of robustness because of the diversity. So we're trying to ask the question, what will it ultimately be? What form will survive the best? Will it be a simple form, or will it be a complex form like the jungle? And I think you were expressing the belief that, or maybe the hope that it will be the more complex form.
Yeah, I don't know. I just think that there are these two options, and I have no idea what is more likely. That's why I was asking what is your opinion, but of course it's just guessing, right?
So my opinion is that we shouldn't decide. Like, who are we to decide, how the universe is going to evolve? And it's more exciting that way. And like, we shouldn't be in charge of the long-term future. I think what's the most, good and evil? What's the most evil thing? Like making a choice that will affect permanently the long-term future. So, if anyone's saying, "Oh, I want to make the future safe," they're really saying, "I want to control all the long-term future. I want to make sure that something can never happen." So who is this person that thinks he can? Yeah, and can there be one person, or are there many people there? I'm going to determine the long-term future. The other guy says he's going to determine the long-term future. There's only one long-term future. There's many of us, and how do we decide? Well, what I'm getting to is that we don't decide. The world, the universe is out of control. No one is in charge. You're not in charge, obviously, but also, you know, the good and the great, the government leaders, they are not in charge either. They're just barely making through the day. They're not the good and great. It's good that they're not in charge. I like the world being decentralized and continuing to evolve. And we'll see how you know, I think it's a grand adventure.
Still on the philosophical note, one of the main goals of critique of pure reason was to set limits to applications of our reason. In analogy, shan't we set limits to applications of AI? It's on the left.
So I think I've answered that one. I don't think we should set limits to what can happen in the universe. Yeah.
So do you want to pick one more question or two?
I guess Kant wasn't trying to set limits. He was trying to explore what the limits were.
What is the difference between totally unrestricted collaboration and anarchy? Where is a pragmatic and or useful boundary?
Anarchy is kind of a loaded word. It means without rulers. It doesn't mean without rules. Like decentralized institutions are full of rules. If there's a difference, it would be that the decentralized ones, you have to join them. You have to sign up for the rules. You don't have the rules imposed on you. So cooperative systems are full of rules. It's not anarchy. Decentralization is not anarchy.
Maybe a follow-up question. Richard, are you advocating libertarianism?
Am I advocating, say...
Libertarianism.
I am a libertarianism. I am a libertarian, absolutely. Yeah. But I see it, I like to present the point of view as I did today, that it's all about decentralization, that we don't want an ultimate master, and we want people to cooperate. If people are cooperating, two people agree voluntarily to go in interaction, not only is the sum positive, but each one is getting is benefiting from the interaction. So this is the gold standard, and it's very hard if you authorize one person to force an interaction, even if both parties don't benefit from it, then it's very hard to ensure that in the long run it actually is a positive sum interaction. It's a good interaction. Yeah, I'm a libertarian.
And on that note, I would like to thank Rich Sutton and Tomáš Mikolov for the very stimulating discussion and letting us pick their brains. They will surely stay for a tad longer, so do have the courage to approach them. They are very approachable, as you can see. And thank you so much for coming. There is food, there is beer, there is more drinks. So we strongly encourage you to stay for a bit longer, or for as long as you can, till about 11:30. And have a great night.